Okay, so let's take a second and actually try to prove this. This theorem. So if m is the midpoint of AB, that's our given, and you'll see this in 2-column proofs a lot. We start out with 1 being the midpoint, or 1 being m is the midpoint of segment AB, and that's given to us. I'm kind of using my line here. We'll extend it down. Increase the size a little bit. Oops. Boom. Okay. So if m is the midpoint of AB, that's told to me. We're told that. Okay. So how can I prove that AM is half of AB and MB is half of AB? Well, I'm thinking, I know that I can say, since M is the midpoint, I know that I can say that AM is equal to, congruent to MB. So I could say that segment AM is congruent to segment MB by the, remember, if we look at our previous, the definition of a midpoint allows me to say that. I know that M's the midpoint, and so I can say that those two are congruent. Okay, so then that means that that's the definition of a midpoint. Of a midpoint. Okay, and then, well, what can I say here? Well, I know that these two are congruent, so, well, let's see. I also know that M is between A and B. So if you remember the first thing we talked about, and maybe, I don't know, you could do this in a different order, but remember the first thing we talked about, if B is between A and C, then AB plus BC equals AC. So I need to somehow get AB in here, right? So since M is between A and B, I know that, well, yeah, we'll keep going with this. I know that AM plus MB is equal to AB, right? That's our segment addition postulate. Okay, and now, so I'm thinking, well, if I can somehow substitute in AM for MB, well, then I can have 2AM equals AB, and then maybe I can get AM equals half AB. So let's try that. So before I do that, I need to convert, because here, this is segments, not lengths. So I know that AM is equal to MB. That is by the, what's that? The definition of congruent segments. Looks like I'm going to run out of room here. I might need to increase my, I'm going to need to increase how large my, gosh, I always do that. Okay, there we go. Okay, I just needed to make my canvas a little bit larger. So, okay, so AM is equal to MB by the definition of congruent segments. Remember, we talked about that a little bit earlier. And that's just to convert from segments to numbers. Okay, so now that I can say these two are equal, well, what if I just put this here, right? Since AM plus MB equals AB, well then AM plus AM equals AB. And this is something we talked about when we went over algebra proofs. I'm using substitution, right? So that's the substitution, and a lot of people, that's substitution of equality, right? That's the substitution property of equality to say that AM equals MB, AM plus MB equals AB, so AM plus AM equals AB. Now this next step is, we don't really have something for it. 2AM equals AB. If you ever have to do something like that, we would just say combine like terms. And then, well, hopefully you can see, if I wanted to get I'm trying to get, if you remember, I'm trying to get to AM equals 1/2 AB. So I need to get AM by itself. That would be probably dividing by 2 if I have another color, right? Dividing by 2. So that's when you divide by 2, or maybe because of the way this problem is worded, we'll say let's multiply by 1/2, right? Can I do that? Yeah, that's fine. I'm okay with that. So that gives me AM equals 1/2 AB by the multiplication property of equality. And then earlier, remember we said AM equals AB. So last up is, again, another substitution. Or, this isn't really substitution, because now I'm saying MB equals 1/2 AB. And that's not substitution. It's kind of almost a special type of substitution. That's the transitive property. Property of equality. Because I'm saying AM equals MB and AM equals 1/2 AB. So MB equals 1/2 AB. This is not really in the proof, but if you can draw, remember, if you can draw equal signs, if I can say AM equals MB equals 1/2 AB, if I can have a continuation like that, then it's transitive. Okay, so that's the proof, and that's and so because we proved it, now we can say definitely, here's the entire proof, right? That we were able to say AM equals 1/2 AB and MB equals 1/2 AB. And that's the midpoint theorem. So you have to prove that. You can't just say it. I mean, obviously now we can say it because we proved it. But, right, normally, I guess if I'm talking just you and I are having a conversation, I say, oh yeah, M's the midpoint, so AM is 1/2 AB and MB is 1/2 AB. You might say that makes sense to me, but if we really drill in, then this is what that proof would look like. And so theorems are proved. They're not postulates, they're not assumptions, and they're not definitions, which are things that we kind of not make up, but we ascribe certain properties to. Yeah, and so that's segments. Hopefully this is a good start for you in thinking about how to get going with proving different things using different properties.